It's December, and you know what that means. Finals time. And with all the cramming for tests and last-minute projects needing to be turned in, it can be a tad stressful. So I thought I'd kill two birds with one stone and stress bake for my thermodynamics group project. In this video, my group members and I will walk you through finding the mathematically perfect time to bake a lava cake. We followed the recipe found in the Binging with Babish video titled Chocolate Lava Cake from Chef. So, without further ado, let's get cooking.
First, we found the BO number of a cylinder using this equation, with volume being pi times radius squared times height, and area being 2 pi times radius times height plus 2 pi times radius squared.
Because the BI number of a cylinder is greater than 0.1, we cannot use lumped analysis, so we will also have to find the BI number of a plane wall using this equation, with the characteristic length being half the height. Since the chart we have doesn't have values for our BI numbers, we have to interpolate using this formula, where x is the BI number, x1 is the given BI value on the graph that is lower than the one we found, x2 is the given BI value that is higher than the one we found, y1 is the lambda or a1 value that corresponds to the x1, and y2 is the lambda or a1 value that corresponds to the x2. Plugging all that in, we get the lambda and a1 for a cylinder and the lambda and a1 for a plane wall.
To get the dimensionless temperature, we use this equation with T infinity being 466.48 Kelvin, T naught being 339.26 Kelvin, and T initial being 282.87 Kelvin. The dimensionless temperature is the same for both a cylinder and a plane wall. Now that we have the lambda and A1 for cylinder, we can plug them into the center of a cylinder equation, which when simplified looks like this, and when rearranged to get tau looks like this. Once all our values are plugged in, we get a tau of 0.2859.
Now that we have the lambda and A1 for a plane wall, we can plug them into the center of a plane wall equation, which when simplified looks like this, and when rearranged to get tau looks like this. Once all values are plugged in, we get a tau of 0.5141.
With both the tau of a cylinder and the tau of a plane wall, we can now get the time by using this formula reworked like so. Plug in the various values and solve for the time of a cylinder and a plane wall respectively. Average them together to get the final time of 2.42 hours. It should be noted that this time is acceptable for a regular-sized cake at a low temperature, but for a cake pan of 3 inches across, as is customarily used for lava cake, it is better to put them in for 20 minutes.